Hi there, in this video I'm going to go through this one example here that is going to help us to understand how we can use definite integrals to find change from a rate of change. So really this is a differential equation we're given in this situation. A differential equation is just one that involves a derivative, and in solving differential equations, which is a huge branch of maths, we're going to use integration. So we've got a derivative and we want to go backwards to get the original function. So we've seen these kind of questions in context with distance, speed and acceleration and the relationship between those things. So we've got displacement, I'll use distance we've travelled, and then we differentiate to get velocity, then we differentiate again to get acceleration, and if we're going backwards we integrate and we integrate. So we've done that. So this is not speed, distance and time kind of stuff. This is a different context. So we've got an oil tank here. It's drained of oil such that the volume of oil in the tank after t minutes after draining commences is that. So this is giving us the rate of change of the volume, okay? The rate the volume is changing in the tank with respect to time. So if we look at the graph of this, and it's always good to draw graphs. So 2t minus 20. So it really doesn't make sense to talk about negative time. So my axis there really should look like this. Okay, so this is time along here. And so this is 2t minus 20. So we can draw this. So it starts off at minus 20 and it goes up like that. Okay, so this is dv dt. This is the rate that the volume is changing. So we start off here at negative 20, and I reckon that's going to be 10. So we've got up 20 and across 10. So the gradient is 2. Okay. So what's going on here? The rate of change. So the rate of change starts off negative and it gets more and more and more and more. Initially full tank is emptied in 5 minutes. So after 5 minutes there is nothing left in the tank. So I could write down that when t is equal to 5, v is equal to 0. Alright, so the first question is saying, write an expression which, if evaluated, would give the number of kiloliters of oil drained from the tank in the first minute. Alright, so we've got this expression dv dt 2t minus 20. To get, really this is what we're doing. We're really kind of integrating like this. We're integrating both sides, and over here these derivatives behave like fractions, which is really cool. So really this is what we're doing. I'm getting a bit technical here, but this is really what you're doing. So the integral of 1 with respect to v is just v. So the volume is, now we're going to do the integration with respect to t squared minus 20t plus c. Okay, so that gives you the volume in terms of t at any time. Now if I'm given some more information I can find that value of c. But the question says, what is an expression which would give you the number of oils drained from the tank in the first minute? Well, that's the definite integral now. Now we're talking about the definite integral. The amount of volume here is going to be the integral from 1 to 0 of 2t minus 20. Now in that first minute, and you can see from my diagram here that it's going to take 10 minutes before we get to 0 here. So they're saying that at 5 minutes here, the tank is empty at that time there. So during this whole time, the rate is still negative, which means the volume is decreasing. Okay, so this value here is going to be negative when we calculate this. So if we want an expression for the number of kiloliters, then I guess we could chuck a negative there at the front. I'll do it in nice big red. We could chuck a negative out the front, and that then would give us the actual volume. Now if we want to then find in part B the number of kiloliters of oil drained from the tank in the 4th minute. Okay, in the 4th minute. So that would be, okay, the 4th minute, we're going to go from 4 to 3. Okay, so how much volume is out of the tank after 4 minutes? minus how much volume was in the tank after 3 minutes. That is the amount of volume going out in the 4th minute. Okay, 2t minus 20. Now notice I don't have to calculate the value of c here, because if I do add c when I do the integration, it's just going to cancel out. So t squared minus 20t between 4 and 3. So 4 squared minus 20 times 4. So I substitute 4 in, subtract, substitute 3 in really carefully. And I know here, I'm going to get a negative number. I know that's going to happen. So what do we got? 16 minus 80, subtract 9 minus 60. And if you do that on your calculator, you should get negative 13. Like I said, I was expecting that. I was expecting to get negative 13, so that just tells me that the volume's going out at 13 during that time. So there was actually 13 kilolitres were drained for the tank in that 4th minute. This is a really kind of basic introduction to differential equations as well, so that's how you do that problem.